Alright guys, we're in section 7.4 and I'm actually starting off in page 207. I wanted to do this so that you didn't sit here and watch me make this whole table because it's kind of tedious. With writing like this, it's kind of a pain in the butt. So I wanted to make it ahead of time and show you. So go ahead and skip forward to page 207, section 7.4, two-way tables. A two-way table is just a, let's see, I don't have to put the definition in the same color. Table that shows data falling into two categories. So in this case, in my made-up scenario, we have surveyed 100 freshmen. And we asked them whether they played a sport. And the other one is to figure out whether they take Math 1 or whether they do not take Math 1. They might be in Math 2 or Math 3 or whatever math class they're in. And we got these fake numbers. So I'm going to go through these definitions one by one, and instead of giving you definitions, I'm just going to give you definitions by example. So the joint frequency here in this dark teal-ish color is just right here. So the joint frequency is just the number of students within each category. So in this case, 40, 25, 5, and 30 are all joint frequencies. That's this one. For marginal frequency, if you think about the margins of the paper, those are the ones off to the sides, right? The sides and the top and bottom. Then the margin also is off to the sides and the top and bottom. In this case, just the bottom. So the margins are 65, 35, 30, and 70. How do you get that? You honestly it's just the total. So the marginal frequency, you might just think of as, let's see here. The marginal frequency is the sum of, the sum of the joint, why does it keep doing that? Okay, frequencies. So you just have to add the joint frequencies. So 40 plus 25 gets 65, 25 plus 5 is 30, and so on and so forth. The joint relative frequency, so now when it says relative, so this is just the number of students at all. 40, 25, 5, and 30. But I said we surveyed, how many students did we survey? 100 in total. So I'm going to take this total and just drop it off right there. 100 total. What the heck, man? 100 total, and the joint relative frequency is the joint frequency divided by the total. So you have 40 divided by 100 is 40%. You could express this as a decimal or a percent. I'll put that in. Can be expressed. What the heck, man? Do I have to change colors or something? Let's try that. Can be expressed. Nope. Expressed as a percent. Why? Why do you do this? As a percent or decimal. I guess when I type slowly, it doesn't do that. All right. Well, anyways, can be expressed as a percent or decimal. Here I chose to express them as percents. The marginal relative frequency is the margin frequency compared to the total. So 65 over 100, 35 over 100, 30 over 100, 70 over 100. The conditional relative frequency, so the condition is this. This one might be the only one that gives you any hiccups, so I'm going to spend a little bit more time talking about this. Let's say if I asked you, out of all students who play a sport, how many take Math 1? So normally, in all these other ones, we looked at the 100 total. But I had said, for example, and I will write this out. Example of all students that play a sport, how many take Math 1? In this case, it says of all students that play a sport. So what this means is instead of looking at the 100 total, I'm going to look at the total of students that play a sport first, and then I will say how many take Math 1. So say 40 out of 65 is, and that's how you set up the ratio, 40 divided by 65 as a decimal percent. 61, this is just an about, 61.54%. Again, so this part right here is very important. Of all students that play a sport, that means I only look at the number of students that play a sport. This is really important for you to be able to make these distinctions when you see them verbally, so you calculate correctly. All right, now finally, let's get into some, all these is just definitions that I just went over. So let's go over these. Find and interpret the marginal frequencies. Find. So really, this is just, marginal frequencies is just totals. That's just another word for totals. So 98, and the way you get that is by addition. So 98 plus 132, 230. 120 plus 88 is 208. 132 plus 88 is, let's see, 210, 220. And this is going to be 120, 218. Yeah, 218. And when I add them up, either way, these margins or these margins, I will get the same number, 238. It says find and interpret. So I'll give you a couple interpretations just to get you started. You might say there were 230 males surveyed. There were 208 females surveyed. And then you would say out of the 208 people surveyed attend college, and then 220 people surveyed do not attend college. This one is exactly the same except with this situation. Own a car, yes. Own a car, no. Do not own a car, male and female. But you just have to add and interpret. You conduct a survey that asks 85 students whether they are in math club or chess club. So let's say, break it up like this, 85 total. So I know that no matter what, if I add the marginal frequencies, they have to add up to 85. So let's say math, yes, no. Chess, yes, no. 35 of the students are in math club, so math club, yes, 35 total. And 20 of those students are also in chess club. That means 20 are in both. 38 of the students are not in math, or 38 neither. Organize the results in a two-way table, include the marginal frequencies. So now let's look. If I know that there are, now remember, all this is just addition and subtraction. So if I know that the number of students in math club are 35, so 20 of them must be in chess club because it says so. But if there are 35 in total, what do I have to add to 20 to make 35? Oh, 15. 20 plus 15 is 35. Or you could have said 35 minus 20 is 15. Whatever way you want to do it. It says to include the marginal frequencies. Well, I know that the marginal frequencies have to add up to 85. So this must be 50. And then to get this, since I know that these two numbers have to add up to 50, I could subtract 50 minus 38. I get 12. So this all checks out. 32 here. 40, 53. 53 plus 32 is 85. 35 plus 50 is 85. And this is the breakdown. There you go. If you need to rewatch it, go ahead and do that. Make sure you get it. Show the joint and marginal relative frequencies. So really this just means find the total and then divide everything by the total. So like 96 divided by whatever. Let's see. 96 plus 80, 176. 54 plus 88. 50 plus 80 is 130. 130 plus 12 is 142. Let's see. 200, 310, 318. So you take all these numbers and you just divide it by 318. Each joint frequency and marginal frequency. So that means you have to add these as well. 96 plus 54 is 150. 80 plus 88 is 168. So again, to get the relative frequencies, you'll be dividing all of these by 318. So for instance, 96 divided by 318 as a decimal is 30.19 or 30.19%. If you whether you express it as a percent or a decimal, it doesn't really matter. Hey man, chill out. Shh. So again, you'll just do that for all these frequencies. Divide by 318 and find the percent or the decimal. Doesn't matter. Okay, moving on. Lastly, a company is organizing a baseball game for the employees. The employees are asked whether they prefer to attend a day game or a night game. They are also asked whether they prefer to sit in the upper deck or lower deck. Make a two-way table that shows the conditional relative frequencies based on the row totals. Okay, so this is given that an employee prefers to go to a day game. Okay, so again, conditional relatives depend on what we're saying. Like, it's not the total anymore. It's the total in that particular column or row. So 28 plus 22 is 50. 34 plus 52 is 86. So they surveyed 136 in total. That's not important. Conditional relative frequencies based on the row totals. Oops, sorry. So it says row. So that was dumb. Rows are horizontal. 62 and 40. 22 plus 52 is 74. So that means it's asking you to just divide each of these numbers by the total. So 28 over 62, 34 over 62, 22 over 74, and 52 over 74. So I will copy this, and you'll have to make it yourself. But I explained it to you. I will do an example for you. 28 over 62. Again, just using the row total. So this will be divided by 62. This will be divided by 74. This will be divided by 74. So 28 over 62 is just a shade under half. How much exactly? 28 divided by 62, 45% or 0.45. 45.16%. Given that an employee prefers to go to a day game, so you know that you're only looking in this column. Given that an employee prefers to go to a day game, what is the conditional relative that he or she prefers to sit in the lower deck? So it's basically just asking you for this. So 34 over 62, which is going to be more than half. How much more? Let's find out. 34 divided by 62, 54.83%. 54.83%. And I have answered this question. 54.83%. All right, guys, that's it for two-way tables. Honestly, it's just being careful. Like, most of the work is just addition and subtraction to finding totals. If you don't understand anything, make sure you ask your teacher or let me know.